In this video, we're going to continue topic 8.2. We're still working on example 2, and we're going to work on part C. So to find the total distance of the space shot travels during the time interval between 0 and 14. So what I'm going to do is I'm actually going to come up here just so you can see how to reference this table up here. So I'm looking in this table for total distance. If you don't remember it, this is the place to go look. So I see total distance traveled by the particle over the time interval. So to get total distance, we need to use the absolute value of the velocity. So we're going to integrate the absolute value of velocity. So let's take a look at that. So we would write it out as total distance equals the integral from 0 to 14 of the absolute value of velocity dt. So I'm going to go back up to my graph where I had all of my areas, and I'm going to use the areas that are there from 0 to 14. So I'm going to do 100. I'm going to use the positive signs though because it's absolute value. So plus 60, plus 40, plus 80. So let's write that down. So it's 100 plus 60 plus 40 plus 80, which is going to equal a total of 280 feet. This part here somehow dropped off, so we're going to write an expression for the ride's acceleration, velocity, and distance. So I'm going to look at acceleration first. I'm going to go back up to my graph, and my graph's a little bit messy, so I'm actually going to do some erasing here on this piece because we need to look at between 10 and 12 is what I'm looking at. So I'm only looking at this chunk right here of the graph. So I know that this is the graph of velocity, so that's the picture, which means that acceleration is its derivative, which means for derivative, I'm looking at the slope of this line. So I'm noticing the slope of this line looks like it's down 20 and over 1. And I know that the graph scaling is really weird on that. So I'm going to go with that it's down 20 and over 1 would just be negative 20. All right, then we're going to talk about velocity. So velocity would just be basically the equation of this line that's right there. So I need to write the, so I'm going to figure out the slope of that line actually. Or actually I have the slope, don't I? I just need to figure out the y-intercept, which I don't have right now. So I'm going to use the point slope formula since I know that this point 10, 0 is on the line. So we'll see if we can get the equation from that and the slope that we calculated for the acceleration. So I'm actually going to not write that quite yet. So we know it's y minus our y value, which we said was 0, equals the slope, negative 20, times x minus the x value, which is 10. So we're going to say y equals negative 20x, negative 20 times negative 10 would be positive 200. Now I'm going to put that in the context of the problem. For velocity, we want to say v of t equals negative 20t plus 200. To get the distance, I know I need to integrate the velocity, but I know I need to start with wherever it's at 10. So the way that I would write that out, so s of t equals, I need to know what s of 10 is, plus I'm going to integrate from 10 to 12 of negative 20. I take that back. It wants me to keep this in terms of t, so we're not going to necessarily know we're ending at 10. So we're going to go from 10 to t, and then I'm going to change this t to an x. So negative 20x plus 200 dx.